pull chain switch is likely located inside the fan housing. However, it may be difficult to spot as it can be hidden behind other components. Use a flashlight and look carefully for a small plastic or metal box or button that is attached to the pull chain. Once you have located the pull chain switch, check if there are 2 wires coming from it. If there are, these wires are the ones that should be connected to the wires inside the fan housing. Here are the steps to connect the switch. Firstly, shut off power to the fan at the circuit breaker or fuse box. Secondly, remove the fan housing cover if it is not already removed. Thirdly, locate the connection points for the switch wires. These points may be labeled or may have different colored wires. Fourthly, connect the 2 switch wires to the appropriate connection points. Fifthly, replace the fan housing cover. Here is how to test the fan. Firstly, turn on power to the fan. Secondly, pull the chain to open the hinge door. Thirdly, the fan should turn on or off when the chain is pulled. Here is how to troubleshoot the fan. If the fan does not turn on or off when the chain is pulled, check the following. Firstly, make sure the wires are properly connected. Secondly, inspect the pull chain switch for any damage or loose connections. Thirdly, ensure that the fan housing is securely attached and that there are no obstructions blocking the airflow. If you've plugged the fan directly into a 110 volts outlet and it works, the motor itself is fine. The issue lies within the switching mechanism activated by the pull chain and the hinge door. The pull chain switch mechanism typically works in conjunction with the door opening. When the door is closed, the switch is off, and when the door is opened via the pull chain, it activates the switch, turning the fan on. Since you don't see an obvious switch, it could be one of a few possibilities. Firstly, the switch is hidden. Some older models have very discrete switches, sometimes integrated into the fan housing in a way that's not immediately apparent. Use a flashlight and carefully inspect the entire area where the pull chain connects to the fan. Look for any small box, lever, or button that might be the switch. It could be a simple on-off switch or a more complex rotary switch with multiple positions. Secondly, the switch is missing. If the homeowner says they didn't open the unit, it's less likely, but still possible, that the switch somehow detached itself. Look for any signs of where a switch might have been mounted, like screw holes or broken plastic. If the switch is missing, you'll need to replace it with a new one. Make sure to get one that's rated for the voltage and amperage of the fan. Thirdly, the wiring is disconnected. You mentioned finding 2 disconnected wires. These are almost certainly the wires that connect to the switch. The switch acts as an interruption in the circuit, and when it's closed, it allows electricity to flow to the fan motor. With the wires disconnected, the circuit is broken, and the fan won't run unless you bypass the switch as you did when you plugged it directly into an outlet. Fourthly, the door mechanism is broken. The switch might be fine, but the mechanism that's supposed to activate it when the door opens might be broken or disconnected. Examine how the door and pull chain interact. There should be a lever or arm that moves when the door is opened, and this movement should trigger the switch. If this mechanism is broken, you'll need to repair or replace it. To diagnose the issue, follow these steps. Firstly, turn off the power. Always disconnect power to the fan at the circuit breaker before working on it. This is crucial for safety. Secondly, inspect the wiring. Carefully examine the 2 disconnected wires. Look for any signs of damage, like frayed insulation or corrosion. Make sure the wires are long enough to reach a potential switch location. Thirdly, locate the switch mounting point. Even if the switch is missing, you should be able to find where it was originally mounted. This will give you a clue as to what type of switch was used. Fourthly, test the door mechanism. Manually open and close the hinge door and observe how the mechanism moves. Look for any broken or disconnected parts. If you find a broken or missing switch, take photos and notes of the mounting location and wiring connections. This will help you find a suitable replacement switch. When buying a replacement switch, make sure it's rated for the correct voltage and amperage. The fan motor should have a label indicating its voltage and amperage requirement. You can find replacement switches at most hardware stores or online retailers. When wiring the new switch, Follow these steps. Firstly, ensure the power is off. Double check that the circuit breaker is off before starting any wiring work. Secondly, connect the wires. Connect the two disconnected wires to the terminals on the new switch. If the switch has specific terminals for line and load, make sure to connect the wires correctly. Otherwise, it usually doesn't matter which wire goes to which terminal. Thirdly, secure the switch. Mount the new switch in its original location, making sure it's securely attached to the fan housing. Fourthly, test the fan. Turn the power back on and test the fan by opening and closing the hinge door. The fan should now turn on and off correctly. If the fan still doesn't work, recheck all your connections and make sure the switch is functioning properly. If you are not comfortable working with electricity, it's always best to call a qualified electrician. Working with electricity can be dangerous if you don't know what you're doing. Here's a little more detailed information to help diagnose what might be going on with the exhaust fan. Firstly, let's talk about the pull chain switch. The pull chain switch is the most likely culprit, especially if the fan was working previously. The pull chain mechanism usually operates a simple single pole, single throw switch, or sometimes a more robust rotary switch if there are multiple speed settings, although it sounds like yours is just on and off. These switches are typically mounted inside the fan housing, close to where the pull chain enters. Over time, these switches can fail due to mechanical wear from repeated pulling, corrosion, or simply old age. When you say you see two wires inside the fan housing that are not connected, those almost certainly were connected to the pull chain switch. The switch acts as a break in the circuit. When the switch is closed by pulling the chain, it completes the circuit and allows power to flow to the fan motor. To find the mounting location for the switch, carefully inspect the area around where the pull chain enters the fan housing. Look for any screw holes, mounting brackets, or outlines in the housing that would indicate where a switch was once attached. If you can find this location, it will give you a good idea of the type of switch that was originally used. When you locate the mounting point, take note of how the pull chain interacts with the switch mechanism. There's usually a lever or arm that the chain pulls, which in turn activates the switch. Make sure this lever or arm is still intact and moves freely. Sometimes these levers can break or become disconnected from the switch. You can test the switch if you have a multimeter. With the power off, disconnect the wires from the switch and set your multimeter to the continuity setting. With the chain in the off position, the multimeter should show no continuity, meaning the circuit is open. When you pull the chain to the on position, the multimeter should show continuity, meaning the circuit is closed. If the switch doesn't behave this way, it's likely faulty and needs to be replaced. Now, let's consider the wiring. The two wires you found disconnected are likely the power in and power out wires for the switch. One wire would be coming from the power source, usually a 120 volt circuit, and the other wire would be going to the fan motor. To determine which wire is which, you can use a non-contact voltage tester. With the power on, carefully hold the voltage tester near each wire. The tester should light up or beep when it detects voltage in the wire coming from the power source. Mark this wire so you know it's the power in wire. Remember to exercise extreme caution when working with electricity. Even though you're using a non-contact tester, there's still a risk of shock if you're not careful. Before you start reconnecting the wires, make sure the power is turned off at the circuit breaker. When you're ready to reconnect the wires to the new switch, use wire connectors such as wire nuts to make a secure connection. Twist the wires together tightly and then screw in the wire nut. Make sure the wire nut is properly sized for the gauge of the wires you're using. Wrap electrical tape around the wire nuts to provide extra insulation and prevent them from coming loose. Now let's talk about the door mechanism. The hinge door is often linked to the switch mechanism so that the fan only operates when the door is open. This is usually accomplished with a mechanical linkage between the door and the switch. When the door is closed, it presses against a lever or button, which keeps the switch in the off position. When the door is opened, it releases the lever or button, allowing the switch to turn on. If the door mechanism is not working properly, it can prevent the fan from turning on, even if the switch is functioning correctly. Check the linkage between the door and the switch. Make sure that all the parts are intact and move freely. Lubricate any moving parts with a silicone-based lubricant to ensure smooth operation. Adjust the linkage if necessary to ensure that the door properly activates the switch. If the door is not closing completely, it may not be pressing the lever or button far enough to turn the switch off. In this case, you may need to adjust the door hinges or latch. Finally, let's consider other potential issues. Even if you've replaced the switch and fixed the door mechanism, there's still a chance that the fan won't work if there's another problem. Check the wiring connections to the fan motor. Make sure that all the wires are securely connected and that there are no loose connections or frayed wires. Test the fan motor with a multimeter to make sure it's receiving power. Set your multimeter to the volts alternating current range and measure the voltage at the motor terminals. You should see approximately 120 volts. If you don't see any voltage, there's a problem with the wiring or the circuit breaker. Check the circuit breaker to make sure it hasn't tripped. If the breaker has tripped, reset it and try the fan again. If the breaker trips again immediately, there's a short circuit in the wiring or the fan motor. In this case, you'll need to troubleshoot the wiring or replace the fan motor. If you've tried all of these steps and the fan still doesn't work, it's time to call a qualified electrician. Working with electricity can be dangerous, and it's always best to leave complex electrical repairs to the professionals. Also, consider the age of the fan. If it's quite old, the motor itself might be failing. While you were able to get it running temporarily by plugging it in directly, that doesn't guarantee long-term functionality. The motor windings could be weak, or there could be internal wear that's not immediately obvious. Replacing the entire fan unit might be the most practical solution, especially if it's an older, inefficient model. New exhaust fans are relatively inexpensive and are designed for better airflow and quieter operation. When replacing the fan, be sure to choose a model that's the same size and has the same voltage requirements as the old one. And as always, follow the manufacturer's instructions for installation. Also, check the fan blades. Over time, they can accumulate dust and grime, which can reduce the fan's efficiency and cause it to vibrate. Clean the fan blades regularly with a damp cloth to keep them running smoothly. Finally, consider the ventilation requirements of your kitchen. The size of the exhaust fan should be appropriate for the size of the room. A fan that's too small won't effectively remove smoke and odors, while a fan that's too large will waste energy. There are online calculators that can help you determine the proper size fan for your kitchen. The building code, for example, dictates a minimum amount of exhaust ventilation for kitchens. If you still are unable to solve the issue, consider contacting a qualified electrician, which could be money well spent.